Okay, so this is standard 6, first assessment. So part A is telling us to use technology to plot the data right here, which is just SAT scores corresponding with GPA of students. And so given an X SAT score, the students were found out to have these GPA. And so by using technology to plot that, I went to Desmos and just plugged everything in on the scatter plot. So it looks like that. And then for part B, where it's asking to determine the least squares regression line, it's asking for the best fit line, which you can also find on Desmos, but I had to find it on the calculator, which you can do with if you plug all of the data in statistics and then use the function find least squares regression line, and it shows you an approximate or closest line that can approximate these scores. And so for C, find the centroid of the data, which is just the average of X and then average of Y. Ensure that the least squares regression line passes through the centroid. And so for the average SAT score of all 7 students, I found it would be 567.143, and the average GPA corresponding to those SAT scores were 3.243. And if I put in 567.143 into my best fit line again, or least squares regression line, I found that Y equals 3.243, which checks out with the centroid. And on E, where it's saying based on the least squares regression line, what GPA is expected for an SAT score of 750. So you can just do the following, where you plug in 750 into the equation again, and you're expected to find to see that the student with a 750 SAT would also have a 4.25691 GPA. And so F is giving you GPA and you're told to solve for X SAT. So there's 2 ways you can do it. You can do it just by putting 2.8 into the front of the equation into the Y, or you can make inverse function, which just isolates the SAT variable into a its own function. And so you can do it both ways. So I did it both ways. So I plugged it back. 2.8 equals 0.005546x plus 0.97413. You solve that out to get x equals to 487.304. And then for the inverse function, you want to isolate x into the dependent variable and y into the independent variable. So I just changed y to x, which is just like, this is actually the GPA now. That's SAT. And so you isolate x, move over the 0.097413, the same side, divide everything by 0.005546, and so you have the inverse function right here. And then now you can just plug in GPA to find SAT, which is also 487.304, which are the same. That's it.